Any doubts? Question number 7. Second. What is the 7th question? Did you get the answer? Huh? Did anybody get the answer for this? So again, in this case, so not every function first of all can be integrated, and we've not studied the different ways of integration. We've only looked at one way, which is integration of substitution, and also within substitution we've only looked at one specific kind of substitution. So in this case, if a function is given and its derivative is given, in that case we said assume the function to be u. So what is the derivative of the denominator? If you differentiate the denominator, what will you get? 6x square plus 4s. And is this given to us? Yes. If you look at the numerator, what is there? 3s square plus, if you look at the numerator, it is 3s square plus 2. So if I take 2 common, the derivative of this is given in the numerator. So what should I make as a substitution? The entire denominator as u. So let 2s cube plus 4s plus 3 is equal to u. What will be the derivative? This will be 6s square plus 4 into ds is equal to du. Take 2 common. So you'll be left with 3s square plus 2 ds is equal to du by 2. Now substitute this, substitute this and this back into the original equation. So what will we get? Integral 3s square plus 2 into ds, this can be written as du by 2, and this term can be written as 1 by u. So this will become du by 2u. Now whenever you change the variable of integration, so in this case now I've changed to u, so you should change the limits as well. One way is don't write the limits, integrate, then substitute u back again and substitute these limits. Or if you're writing the limits here, then you should change the limits as well. So what is s varying from? S is varying from 0 to 1. When s is 0, what is the value of u? When s is 0, what will be the value of u? 3. So what will be the limits of u? From 3 to, when s is 0, 2 plus 0 plus 0 plus 3, so u is 3. When s is 1, what is the value of u? 2 plus 4, 6 plus 3, 9. So u is varying from 3 to 9. Either don't put the limits here, just integrate in terms of u, substitute u back here again as this, and substitute these limits. But if you're writing limits in this integral, you should write the limits of u. Is this clear? What is integral of u? ln u, mod u, but these are positive. And limits are from 3 to 9. What is ln x minus ln y? What is ln x minus ln y? Ln x by y. So from now on, I'll just whenever it is this ln u upper limit minus lower limit, we can write it as ln upper limit upon lower limit. So I'll write it in this manner. So this will be ln 3 by 2. What is the answer? ln 3 by 2. Any other doubts? What is the answer for first A? Negative 10 by 9. Are others also getting that? Minus 1 by 9 you're getting. What are you getting? Minus 10 by 9. So, in such questions, you have to be careful with the negative sign. So, can I just... What is the first question? Integral 1 by x square minus 4 by x cube dx, and this is varying from minus 2 to 3. So what is integral of 1 by x square? Minus 1 by x. So this will be minus 1 by x, and what is integral of minus 4 by x to power minus 4 by x cube? So this is x to power minus 3. So this will be x to power minus 2 upon minus 2. So this will be 4 upon 2x square. And there's a minus here, so minus minus will become plus. So in the beginning, integrated in this manner, x cube is x to power minus 3. What is integral of x to power n if n is not minus 1? The integral is x to power n plus 1 upon n plus 1. So initially always write it in this manner. So x to power minus 3 plus 1 is minus 2 upon minus 2. So x to power minus 2 is 1 upon x square upon minus 2, minus minus will become plus. Now upper limit minus lower limit. So substitute the upper limit. This is minus 1 by 3 plus 2 by 3 square is 9. Minus lower limit. Now substitute minus 2. If you substitute minus, minus minus will become plus. 1 by 2 plus, this is 2 by x square, and x is minus 2, but square will be positive. So 2 by 4. So what do we get? Minus 1 by 3 plus 2 by 9 minus 1 by 2 plus 1 by 2 is minus 1. So what is this equal to? Minus 12 by 9 plus 2 by 9 minus 10 by 9. What is the answer for the second one? 4 pi by 3. Second one, are you getting 4 pi by 3? Second one, have you done the questions now? At least write the answers. The answers are not given, so check the answers. Anybody has doubt in the second one? What is integral of 1 plus x, 1 upon 1 plus x squared, tan inverse x? Second one, are you getting 4 pi by 3? Second one. Integral 8 upon 1 plus x square dx from 1 by 3 to root 3. Now 8 we can take outside. What is integral of? What is integral of? Integral of 1 upon a square plus x square dx. 1 by a tan inverse x by a. In this case, a is 1. It is just tan inverse x. So 8 into tan inverse x, and from 1 by root 3 to root 3. So 8 into tan inverse root 3 minus tan inverse 1 by root 3. What is tan inverse root 3? For what angle is tan root 3? Pi by 3, and 1 by root 3 is pi by 6. So this will be pi by 6. 8 into pi by 6 is 4 pi by 3. This is 1 by a tan inverse x by a. Third question, what is the answer? What is the answer for the third question? ln3 plus ln2. Are you getting this? This is the answer for the third one. Please check. So in the third one again, what will we take as, instead of u, you can choose some other variable s, it doesn't matter. So what will we substitute? U cube. Take u cube as s or any other variable. Also, which variable I choose, that is unimportant. X squared dx 1 to 2 is same as t squared dt 1 to 2. The choice of variable which you use is not important. What is the answer for the D part? So 1C, this is the answer, ln2 plus 3 by 2. Any doubt in this? Fourth one, what is the answer? Sin x, 0 to pi. Integral sin x dx 0 to pi. What will be the answer? Are you getting to? What will be the answer for 0 to pi? Question number F. Cos x 0 to pi. This will be 0. And this we can answer from the curve itself. This is the curve for sin x. Y is equals to sin x. Where is sin 0? 0, pi, 2 pi. Now, from 0 to pi, the entire curve is above the x-axis. What is the curve for cos x? Cos x curve, both of these are sinusoidal curves. When we say sinusoidal curve, we mean either cos or sine. But cos x, it begins at x equals to 0, it is 1. And this is pi by 2, it is 0 at odd multiples of pi by 2. And this is pi. Now, this area is equal to this area. So when we say graphically, what does definite integral gives us? Area under the curve. We are traveling in the positive x direction from 0 to pi. So area above is positive, area below is negative. This area is equal to this area. So what will be the integral of cos x from 0 to pi? 0. This area will be positive, this will be negative, it will come out to be 0. Is this clear? Now, question number E, integral 0 to pi sine square x dx. What is this value? This is pi by 2, and for cos square x also it is pi by 2. So even for cos square x it is pi by 2. Can you plot the curve for sine square x? This is the curve for sine x. What will the curve for sine square x look like? Can you plot the curve for sine square x? So try to draw. So what is the mistake in this? Try to think. So suppose I want to plot sine square x. This is the curve for sine x. Now, can sine square x be negative? No, it will always be positive. So, generally when students are asked to plot sine square x, they plot it in this manner. But even in sometimes in books they plot it in this manner. This is incorrect. Why is it incorrect? Now, in this case, what is, if you draw it in this manner, what is the slope at this point? It's not defined. If you have a curve like this, slope at this point is not defined. Or if you draw the tangent here, what happened? You can go along with him. Yes. Now, one way to say this is incorrect is the slope at this point is not defined. And when you differentiate sine square x, what is the derivative of sine square x? 2 sine x cos x, and this is defined for all values of x. It has a specific value for all values of x. So, how will we plot? Again, use the double angle formula. What can I write sine square x as? Using double angle formula, what can I write sine square x as? 1 minus cos 2x by 2. Now, what is the curve for cos x? This is the curve for y is equals to cos x. What will be the curve for cos 2x? So this is, this is pi by 2, pi, 3 pi by 2, 2 pi. What will be the curve for cos 2x? Cos 2x will also be the same curve. The only difference is now the points where it will be 0. I'm drawing the x scale differently, so don't compare with the above curve. The curve will look similar. The only difference will be now these points will change. So this will be pi by 4. This will be pi by 2. This was 3 pi, so this will be 3 pi by 4. So what is the curve for cos x? Cos x and cos 2x curves, they look similar. Thank you. So cos x and cos 2x curves, they look similar. This is y, this is x. Only the values where it will be 0, that will change. Now, from cos, this is the curve for cos 2x. From cos 2x curve, I want to plot this curve. So we briefly looked at shifting of curves. Do you remember anything? If this is cos 2x, what will be the curve for minus cos 2x? Minus cos 2x means negative of this. So if I plot negative of this, this will be the curve for minus cos 2x. And if I multiply it by 2, or if I divide it by 2 means, each value will become half. So this is minus, this is plus 1, this is minus 1. If I multiply it by a factor of 2, minus cos 2x by 2, this will become minus 1 by 2 plus 1 by 2. Each value will become half. So this is the curve for cos x. Similar curve for cos 2x. Only the values on the x-axis will change. What is the curve for minus cos 2x? Negative of this. What is the curve for minus cos 2x by 2? Each value will become half. Now add 1 by 2. If I add 1 by 2, how will the curve change? It will shift upwards. So plus 1 by 2. So what will be the curve for? Now shift each of the points up by 1 by 2. So if I shift upwards by 1 by 2, so the curve will look something like this. Y, and this is. So basically this is also a sinusoidal curve, only it has been shifted upwards and the period has changed. So now this is 0, this is pi, and this is 2 pi, and so on. Is this clear? So if I'm plotting y is equals to sine square x, I'm not plotting cos 2x because x will change. So I'm plotting sine square x. So this will be the curve for sine square x. If you're plotting in terms of cos 2x, then this would be pi by 2. So the point I was trying to make was, if this is the curve for sine x, sine square x is not this curve, it is still a sinusoidal curve, which has been shifted upwards. In the second question, any other doubts? How many of you have done the first 3 questions? Any doubts in those? Question number 21st. 21st question is 1 by 2 root x plus 1 by root x whole square. So, what is the derivative of root x? 1 by 2 root x. So, 1 by root x is given in the numerator. Root x is in the denominator, but 1 by root x is in the numerator. So, what is the derivative of root x? 1 by 2 root x. So, what should I choose as u? Root x or 1 plus root x? I'm not sure. I mean, I did not put the asterisk. So question number 21st. So in this case, let 1 plus root x, let this equal to u. Now differentiate this. What is derivative of 1? 0. What is derivative of root x? 1 by 2 root x. This is du. And dx by root x is given to us. The expression is given as dx upon 2 root x 1 plus root x whole square. So assume 1 plus root x is u and dx upon 2 root x is given to us. So what will this become? Integral of dx by 2 root x. This I can write as du. And 1 plus root x is u. So this will become du upon u square. And what are the limits? 1 to 4. No, sorry. The limits are not 1 to 4. The limits are 1 to 4 here. Now one method is either don't write the limits here, integrate in terms of u, substitute u back again as this. Or if you're writing the limits here, change the limits. So when x is 1, what is the value of u? 2. When x is 4, what is the value of u? Root 4 is 2, 2 plus 1 is 3. So one method is either don't write the limits here, integrate, substitute u back again as 1 plus root x and substitute the initial limits, or change the limits. Is this clear? So what is the answer for this? What is integral 1 by u square? Minus 1 by u. U to the power minus 2 is minus 2 plus 1 upon minus 2 plus 1 from 2 to 3. Now there's a minus sign here. Either you can take the minus outside and then write 1 by 3 minus 1 by 2, or this minus minus will become plus. So just be careful in the second case. So what is this? 1 by 3 minus 1 by 2 is minus 1 by 6, minus minus will become plus 1 by 6. When you are subtracting, if you're not taking the minus outside, this will be minus 1 by 3 minus 1 by 2. So this minus and minus will become plus. The expression is minus 1 by u. Or you can take minus outside and then upper limit minus lower limit. Or if you're not taking minus outside, this will be minus of minus. Upper limit minus lower limit. Is this clear? So what is the answer? 21st, 1 by 6. And they've given you also what to take, substitute u is 1 plus root x. Any other doubts? Have you tried the questions? Try them today. Try some questions. Any other doubts? How is the? So cos square will be, what can you write cos square x as? So this will also look something. Both are sinusoidal curves. Cos square will begin from 1. Sin square begins from 0. Cos square will begin from 1. If you want to plot it, basically this is 1 plus cos 2x by 2. Question number 19th. Integral 2 e to the power x plus 1 dx. So what is derivative of e to the power x? E to the power x. So assume u is e to the power x plus 1. So du will be e to the power x dx, derivative of 1 is 0. So this is given to us. So substitute this and this back into this expression. And the limits are minus ln 2 to 0. So what will this become? E to power x dx is du. So 2 du upon 1 plus ex is u. So 2 du upon u. And what will the limits change from? U is e to power x plus 1. So e to the power minus ln 2 plus 1. What is the value of e to the power minus ln 2? So we've seen a property b log x to the base b. This is equal to x. So e to the power ln x, ln means log to the base e. This will be equal to x. So can I write this as e to the power ln 1 by 2? If you take minus inside, this will become ln 1 by 2 plus 1. So this is 1 by 2 plus 1. So the lower limit is 3 by 2. What will be the upper limit? X is 0. So e to the power 0 is 1. 1 plus 1 is 2. And integral of 1 by u is ln u. So 2 ln u, and the limits are 3 by 2 to 2. So ln upper limit upon lower limit. So 2 ln 4 by 3, or you can take 2 inside and square 16 by 9. Any other doubts? Question number 22nd. So in the 22nd question, they've given you what to substitute as well. Actually, they've given you in all the questions. So x into x minus 1 to the power 4 dx from 1 to 2. Now, a very lengthy method is you expand this. You can write it as x minus 1 whole square, and expand it. You'll get polynomials. And for each of them, apply this formula. X to the power n dx is x to the power n plus 1 upon n plus 1. That is a very lengthy method. In this case, they've already given you the substitution to be used. U is x minus 1. So let x minus 1 is equal to u. So in this case, what is dx? Dx is equal to du. And what can I write x as? U plus 1. So make these substitutions here. So what can I write the integral now as? X can be written as u plus 1. X minus 1 can be written as u to the power 4. Dx is equal to du. What will be the limits? When x is 1, u is 0. So lower limit will be 0. When x is 2, u is 1. Upper limit will be 1. Now multiply u to this. So this will become u to the power 5, u to the power 4. So this will be u to the power 6 by 6 plus u to the power 5 by 5 from 0 to 1. Lower limit is 0. Upper limit is 1. 1 by 6 plus 1 by 5 is 11 by 30. Is this clear? Any other doubts? Third, so this one, G. What is the answer for the G part? Third question. So what is the question given as? Average value of average value of e to power sin t cos t from 0 to pi by 2. So now, again, how do we integrate this? Integration by substitution. What is derivative of sin t cos t? So what is average value of a function? Average value of a function is defined as integral f of x dx x1 to x2 upon x2 minus x1. So this is the definition of average value of any function. So they're asking for e to the power sin t. So the variable here is t, doesn't matter whether it is x or t. So f of t is e to the power sin t cos t dt from 0 to pi by 2 upon pi by 2 minus 0. Now, to perform the integration, assume let sin t is equal to u. So what is the derivative of sin t? So cos t dt will be du. And now if I substitute, what will I get? E to the power sin t, so this will become e to the power u. Cos t dt is du. What will the limits be? When t is 0, what is u? 0. When t is pi by 2, what is u? 1. Upon pi by 2. So integral of e to the power u is e to the power u. So e to the power u from 0 to 1 upon pi by 2. What is e to the power 1? E minus, what is e to the power 0? 1. So e minus 1 into 2 by pi. Did you get this answer? Is this clear? So this is the formula for average value of a function. Any other doubts? Yes. So is this clear? What is average value of sin x from answer for 3a? 3a is 2 by pi. What is the answer for B? 0. Answer for C. What is the answer for C? 1 by 2. What is the answer for D? 1 by 2. So these values, in fact, later on for certain chapters, these values need to be memorized as well. But we use them so often, it will get memorized. So when we are studying alternating current, SHM, there the averages of these values are required quite often. What is the answer for E part? So this is for A, B, C, D. What is the answer for E part? Yeah? 32 by 3. Alok, what is the answer for 3E? Has anybody else done 3E part? Eight by 3. Both are getting same. So E is, so the first 4 answers are these: 2 by pi, 0, half and half. 3E is 8 by 3. What is F? So try those questions. I don't think anybody has solved till there. Then we can discuss again. Now, 4 to question number 8. These are theoretical questions. Let's just read them once again. So read the 4th question. These are all theoretical questions. So what is the 4th question? W prime is the rate of growth of a child in kg per year. So what is the meaning of W prime dt 5 to 10? If W prime, W dash is the rate of growth of a child in kg per year, in that case, what is the meaning of this term? Yes. So this is same as net change theorem. Integral of rate of change of a function. Integral of rate of change of a function from any value gives us the net change in the function. So what does this mean? What is the meaning of W prime t? It is dW by dt. So W prime is dW by dt. What is the meaning of this? Rate of change of weight with respect to, or rate of change of mass. Actually, it's mass. It's kg. So it's not weight actually. So rate of change of mass with respect to time. Now, what is the meaning of W prime dt? So rate of change into an infinitesimal time interval. This will give me dW. And what is the meaning of dW? Change in mass. And what is summation of change in mass. It will give me the total change in mass. So the integral of rate of change of a function gives us the net change in the function. Similarly, what does integration of velocity give me? What does integral v dt give me? What is the meaning of, if v is velocity here, what does integral v dt give us from t1 to t2? Change in position. So change in position, so this will be position at t2 minus position at t1. What is velocity? Velocity is rate of change of position. So rate of change of position, v is dx by dt. So what is the meaning of v dt? V dt will give me dx. So velocity into infinitesimal time interval will give me change in position in that time interval. And what is integration of dx? Dx is change in position. So summation of change in position will give me total change in position. Final position minus initial position, which is also known as displacement. Is this clear? So what does this term represent? It tells us the mass gained by the child from the age of 5 to 10 years. So mass of child at 10 years, mass of child at 5 years. So mass gained by the child from 5 to 10 years. Question number 5th. What is the 5th question? If oil leaks from a tank at a rate of r liters per minute, what does integral RT dt 0 to 120 represent? So integral RT dt from 0 to 120. What is R here? The rate at which oil is leaking. So this is dV by dt. You can just write V, but V is for volume. So here, what is the rate here? The rate at which oil is leaking. And how do we know it is volume? From the units. What units have they given us? Liters per minute. Liters is the unit of volume. So the rate at which liquid is coming out or leaking from the vessel is given as R of T. So what is RT dt? If I take dt here, RT dt here, what will this give us? dV. So what is dV? The volume which has leaked in dt time. Now, if I add all the small dVs, I'll get the total volume leaked. And from which interval? 0 to 120. So what is this? Total volume of oil leaked. Volume of oil leaked in the first 120 minutes. From 0 to 120. If it was from 10 to 120 means from 10 minutes to 120 minutes. Is this clear? Similarly, 6th question, current is defined as dq by dt. So what does integral I dt give us? The charge flown from 0 to t. This similar question we done yesterday as well, numerical. So I is dq by dt. So what does integral I dt give us? Summation dq, integral dq, which is total charge flown from 0 to t. Question number 7th. A honeybee population starts with 100 bees and increases at a rate of n prime t bees per week. What does 100 plus this represent? What will be the answer for the 7th question? So what is n? N prime is dn by dt. Here n is number of bees, or I'll just write the units. This is in number per unit week. So this is number of bees So the unit is number of bees per week. Now, what are they asking us? Integral n prime t dt. What is n prime t dt? This is dn. What is the meaning of dn? Change in number of bees. So what will summation of dn give me? Total change in the number of bees. So from 0 to 15. So this will give me number of bees in 15 after 15 week minus number of bees in 0 week. What was the initial number of bees? 100, which means n0 is 100. So what is n15? This will be n0, which is 100 plus n prime t dt from 0 to 15, and this is 100. So what is this telling us? Number of bees after 15 weeks. So what is the integral telling us? Number of bees after 15 weeks. And what is this term telling us? The change in number of bees from 0 to 15 weeks. This plus 100 is number of bees after 15 weeks. So same is in the case of velocity as well. Integral v dt does not give us position. It gives us change in position. X final minus x initial. If they are asking you final position, you will always have to add the initial position. Is this clear? Question number 8. If x is measured in meters and f of x is measured in newtons, what are the units of f of x dx? What will be the answer? Hey, just theoretical, joules. What is the answer for the 8th question? If x is measured in meters, f of x is measured in newtons, what are the units for f of x dx? How does the integration sign change the units? What is the effect of this on the units? It does not change. Integration is basically summation and limit. So what is the unit of this? Newton. What is the unit of this? Meter. So what will be the entire unit? Newton meter. What is Newton meter? In this case, it is called joules. It's not always called joules. Why? In case of torque, when we write, torque is also Newton meter, but there we don't use the units, joules. In this case, we can say joules. Actually, we don't know. So it's Newton meter, but it depends on the quantity. If they're trying to, but they're probably not calculating force, sorry, torque. So we can say joules. That is fine. Try the 9th question. Try the 9th and 10th question right now. Try the 9th and 10th question. Try the 9th and 10th question. 120?
135 million. I just basically wrote this equation. This thing 50, and if we integrate, it will get 50 e raised to t by 2.
So I'll just check if I have the answer. What is? Try to think. What was the derivative of e to the power x? So what will be the antiderivative? ln a. So I don't have the answer key for this, I think. So you can leave it in terms of E. What are you getting the answer as? 50E. I'll just check. Others, please try. It is estimated that the population of a certain country is growing at a rate of 0.02 t million people per year. So population, you can write dp by dt or dn by dt. So n is number of people. So what is e to the power 0.2 t? E to the power 0.02 t, what is this? This is the rate at which the population of a certain country is growing. What is the meaning of rate of at which population is growing? dp by dt or dn by dt. N is number of people. What are they asking us? If the current population is 50 million, what will be the population from 10 years from now? So what is the meaning of dn e to the power 0.02 t dt? This will give me the change in population. What is the meaning of this dn? dn means change in population. So if I'm just writing this term, this is change in population from t to t plus dt. If I take an infinitesimal time period dt, what is dn? Change in population. What is dt? Change in time interval, an infinitesimal change. So dn is change in population in an infinitesimal time period dt. From which dt? From t to t plus dt. Now dn is change in population. If I keep on adding all the change in population for all such small dt's, what will I get? Total change in population. And that summation along with limit is called integration. So summation, dn from n1 to n2, n1 is the initial, n2 is the final, is equal to how much? E to the power 0.02 t dt, and t is varying from 0 to 10. And what are the units of this? This is in million per year. So what is n final minus n initial is equal to, what is integral of e to the power x? E to power x. E to power ax is e to power ax upon a. So e to power 0.02 t upon 0.02, and the limits are 0 to 10. So n2 is the final population. What is n1? Initial population is 50. This will become e to the power 0.02. E to the power 0.2 minus e to power 0 is 1 upon 0.02. And what is the value of 1 upon 0.02? It is 50. So n2 is 50 plus 50 plus e to the power 0.2 minus 1. 50 and 50 will cancel out. So the answer will be 50 into e to the power 0.2 million. Is this clear? Just check if there is any mistake in this. I think it seems correct. Please check the calculation. I don't have the answer for this. Is this clear? Try the 10th. Next question. Please perform the integration on your own completely. So upper limit minus lower limit. When you substitute 10 here, you'll get 0.02 into 10 is 0.2. E to power 0 is 1. $50 into minus 1 will be minus 50. This 50 and 50 will cancel out. Is it clear? Try the next 10th question. Try the 10th question. So what can I write? V as dx by dt. So dx can be written as integral v dt. So what are they asking us in the question? The distance covered. What does v dt tell us? What is the meaning of v dt? Distance covered in time interval. So this is the distance covered from distance covered from t to t plus dt. In this infinitesimal time period, from t to t plus dt, the distance covered is v into dt. So what is the total distance covered? Summation of all the distances. If I divide the entire interval into small dt intervals, the summation of distance covered in each dt interval will give us the total distance traveled, which is integration. What will be the limits of integration? What will be the limits of integration? Adesh, what will be the limits of integration? At least don't disturb others. What will be the limits of integration? Madhav? What will be the limits of integration in this question? 2 to 3. So what are they asking in the question? The distance, how far does the object travel during the third minute? The third minute means from 2 to 3, this is the third minute. From 1 to 2, this will be the second minute. So third minute means from 2 to 3. So perform the integration, you'll get the answer. What are you getting? 30. So the answer comes out to be 30 meters. Just check. From 2 to 3. Now, last 4 questions I won't discuss in the class. If you're interested, you can ask outside the class. So I'll continue with where I left off yesterday. We were calculating volume of a sphere. So the purpose of doing this right now is sometimes students face difficulty in this. So we'll be doing this many times over and over again. So when you see it multiple times, you'll get used to it. Haan, 30. So the answer for the 10th question is 30 meters. So yesterday we calculated the volume using a disk, a shell, spherical shell. We can also calculate the volume using disks. Suppose this is R, and if I divide this, suppose at a distance y from here, I divide it into very infinitesimally thin disks, and this radius is R. So how did we calculate the volume yesterday? I divided the entire sphere into shells. Then we wrote the volume of one shell. We said I can divide the entire sphere into infinite such shells. And if I add the volume of each such infinite shell, I'll get the total volume. I can also divide it into disks in this manner. Calculate the volume of one such disk, and if I add the volume of all the disks, what will I get? The total volume. Now, so what is the element in this case? So the element chosen here is a disk at a distance y from the center and thickness dy. So what is the thickness of the disk? dy. Now, what will be the volume of this element? What can I write the volume of this element as? What can I write the volume of this element as? So now, the disk is something like this, but if dy is infinitesimally small, if this is dy, now as you keep on decreasing dy, if dy is infinitesimally small, can I take this thickness, can I treat it as a cylinder almost? If the thickness is not small, then I cannot use the volume of a cylinder to write then I cannot even call it a disk actually. So the only reason for calling it a disk is because the thickness here is negligible. dy is infinitesimally small. Infinitesimally small means as small as possible you can imagine, 0.000. Is this clear? If dy is infinitesimally small, in that case, can I treat it as a cylinder, a disk? So what can I write the volume of this element as? Pi r square into h. What is the height? dy. And what is the value of what is the radius of this disk? What is the volume of a cylinder? Volume of a cylinder is pi r square h. A disk is basically a thin cylinder is called a disk. If the height is very small, we call it a disk. In this case, technically it is not a disk, but if I take dy is infinitesimally small, this will almost be negligible. So I can treat it like a disk. What will be the volume in this case? Pi r square dy. What can I write r as? If this is r, small r, this is capital R, this is y. What can I write small r as? R is under root of r square minus y square. So what will I get here? dv is equal to pi r square dy, and this will become pi r square minus y square dy. So is this much clear? Is this clear? Now, this is the volume of this disk. If I divide this into infinite such disks and add the volume of each disk, I'll get the total volume. And this addition along with the limit is called integration. Now, what will be the limits of integration? So this is pi r square minus y square dy. What will be the limits of integration here? What will be the limits of integration? Where will y vary from? 0 and theta. 0 to capital R. Anyone else? What will the limits vary from? I want the limit such that the entire sphere is covered. So what should be the limits? What should the limits of the integral be? What will the limits of integration be in this case? So I want to vary y in such a way that the entire sphere is covered. So where am I measuring minus r to r? So now, and here you cannot write 0 to 2r. Then you'll get an incorrect answer. Another way to solve is, this is an even function. So the limits minus r to r can also be written as twice of 0 to r. What is the meaning of integration from 0 to r? I am measuring y from here, from the center. So if y is varying from 0 to r, I'll get volume of only top half of the sphere. Is this clear? So one method is I can integrate from 0 to r and then double it. I know the volume of the top half of the sphere and lower half will be same. So one method is integrate from 0 to r and then double it. But if I want to cover the entire, what should be the limits? Y should vary from this point to this point. So, but I'm measuring y from here in this direction. So this is the positive direction. So what will be the value of y at this point? Minus r. And where is y varying from? Minus r to plus r. So what will be the limits of integration? Minus r to plus r. Now, why don't I write the limits as r to minus r? Can I write the limits as r to minus r? So we don't write the limits as r to minus r. Why? So this I explained yesterday. The direction of the integral also depends on the direction of traversal. So generally we always move from in the direction of increasing variable. So y is increasing from minus r to r. If you write from r to minus r, you will get the volume as negative. Is this clear? So generally whenever we are integrating, we always integrate in the direction of increasing x or increasing y. Is this clear? Now, if you use the property of an even function, This is an even function. What is the meaning of even function? If f of x is equal to f of minus x. So if I replace y by minus y, this function will remain the same. So what was the property of an even function? This is the total volume. This can be written as twice 0 to r pi r square minus y square dy. And this we can have written directly as well. 0 to r gives us volume of half of the sphere, and twice means double of it. But this we can also write from properties of a definite integral from minus a to a. This is an even function. Now just integrate this. So what will be the integral? V is 2 pi into, what will be integral of r squared dy? What will be the integral of this? Please calculate. What will be the integral of this? What will be the, Joel? So this, even if you're not able to understand, just put in the effort, try to understand. This we'll be using many times, you'll get used to it. This is not needed immediately. What will be the integral of r squared dy? What is the integral of, what is integral of dy? Y. What is integral of 2 dy? 2y. Capital R is a constant here. So what will be the integral of this term? 2 pi into r square y. R square is a constant. What is integral of y square? Y cube by 3. Upper limit minus lower limit. So it is easier to calculate from 0 to r, otherwise you'll have to subtract minus r. So this is convenient. So this will be 2 pi. What is integral of, sorry, not integral, just substitute r here. So r cube minus r cube by 3, and lower limit will be 0, minus lower limit. But when you substitute 0, you'll get 0. R cube minus r cube by 3 is 2r cube by 3. So this will come out to be 4 pi r cube by 3. Is this clear? One last integration. What is the surface area of a sphere? 4 pi r square. So try to derive surface area for a sphere. So just try to think, what I meant to try to derive was, just think what kind of element should you choose. So no need to solve, just think for surface area of a sphere, what kind of element should you choose. So just try to think, if I want to calculate surface area of a sphere, what kind of element should I choose? What kind of ring? Now, if I want to calculate surface area of a sphere, what kind of element should we choose? So the element has to be on the surface. So what kind of element can I choose? A ring on the surface. So in this case, now what variable would you choose to write the thickness? So in this case, it is convenient if you use the angle theta. Suppose for the lower ring, if the angle that it makes, the radius vector, with the radius vector, if this angle is theta, and at an angle theta, this is d theta, what will be the thickness of the ring? So what is the element chosen? Element is a ring at an angular position theta, and what is the thickness of the ring? What will be the thickness of this ring? What will be the thickness of this ring? What will be the radius of this ring? What is the thickness of this ring? Yes. So this here, this length, it represents the thickness. Sorry. If this angle is d theta, what can I write this length as? Rd theta. So thickness is Rd theta, and the ring from this, if I'm measuring the angle from this diameter or on this surface, the angular position that the radius vector makes with this plane is theta. Now, if this is theta, this will be the radius, this is r. What is the radius of the ring? Radius of ring element. What can I write the radius of the ring element as? Small r. What is the value of small r? R cos theta. For this ring, so this ring is on the surface of the sphere, but what is the radius of the ring? Radius of the ring is not capital R. It is this length. And what is this length? R cos theta. So even if you're not understanding, just try to understand. This will revisit many times, you'll get used to it. So what is the radius of this ring? R cos theta. Is this clear? So radius is R cos theta. Now, what can I write the area of the ring as? If this much is clear, what can I write the area of this ring as? What can I write the area of this ring as? Curved surface area? Curved surface area of a cylinder. But what will you write it as? That is the question.
by using of 2 pi r square. Shouldn't it work? Like if you imagine a sphere, if you add up all the parameters like width or everything, isn't it equal to surface area?
Shouldn't, if you add,
All the like small surface area of the small circles, you should end up with the total area.
why should you add up? The projection will be equal. Basically, if, please try to think what will be the area of this element. Now, so basically, the area of this ring and the area of this ring is not same. Suppose you take an area here and you take an area here. This ring's area and this ring's area is not same. So basically what you've done is you've compressed it. And then you're saying this area is equal to this area, but they're not equal. Why are they not equal? Try to think. So when if you try to write, Alok, if you try to write the thickness of it, you'll understand why that is incorrect. So what can I write the thickness of this as? Sorry, this I've already mentioned. What is this length? R d theta. So the thickness of this ring element can be written as r d theta. Is this much clear? Now what can I write the area as? How did I write the area in this case? When we were calculating the area of a circle, we again took a ring element. For area of a circle also, you could have chosen strips like this. So just as we calculated the volume of a sphere using spherical shells and discs, for area of a circle, if we choose rectangular strips in this manner, the integration is simpler using ring. We could have done area of a circle also in this manner. So how did I write the area of this ring as? Circumference into thickness. So what is the circumference? 2 pi r dr. Is this clear? So in this case, circumference was 2 pi r, thickness was dr. Now, same method, circumference into thickness. What is the circumference of this ring? What is the radius of this ring? Small r. So what can I write circumference as? 2 pi small r. And what is the thickness of the ring? R d theta. Now, what is the value of r? Substitute r back again. So this is r cos theta, r into r d theta. Now, for total area, what will be the limits of theta? 2 pi r square is constant. What will the limits of theta be in this case? What will be the limits of theta? So one method is, so how do we determine the limits? Choose theta in such a manner such that the entire surface is covered. Where am I measuring theta from? From this point. If I vary theta from 0 to pi by 2, only the upper half will be covered. So at a particular theta, this surface, this portion of the sphere is covered. So if I vary theta from 0 to pi by 2, the top half will be covered. So one method is 0 to pi by 2 and double it. But if I want to write the entire units, where should theta vary from? Minus pi by 2 to pi by 2. Suppose I had taken the ring element in this manner. I can choose rings in this manner as well. Now, what would be the limits of theta? In this integration, if I want to cover the entire surface of the sphere, what will be the limits of theta? Pi to? Think again. What will be the limits of theta in this case? So we're just learning how to write the limits. Suppose I could have chosen, instead of horizontal rings, I could have chosen vertical rings. So same, if I choose vertical rings in this manner, I'm again measuring theta from here. This is d theta. Now to cover the entire surface of the sphere, what should be the limits of theta? To cover the entire surface, what should be the limits? Johan? Sahi. If theta is 0, basically then there is effectively just a point. If theta is some 10 degree, then you'll get a ring like this. So as you move from 0 to 90, what is covered? As I increase 0 to 90, so from when I vary theta from 0 to 90, the right half of the sphere is covered. To cover the left half, what should theta vary from? I should further increase theta. So theta should vary from 0 to pi. So in this case, the limits would be from 0 to pi. But now the radius will be different. What is the radius? Radius will be r sine theta. Now this is the radius, r sine theta. In this case, this is the radius, r cos theta. In that case, this will be the radius, r sine theta. Final answer will come out to be the same. Now, this is varying from minus pi by 2 to pi by 2. And is cos an even function or an odd function? Even function. So the limits are from minus a to a. I can write it as twice of 2 pi r square cos theta from 0 to pi by 2. So area will be 4 pi r square. What is integral of cos theta? Sin theta 0 to pi by 2. So this will be equal to sin pi by 2 is 1, sin 0 is 0. So area is 4 pi r square. Is this clear? So Alok, in your, what you were doing was, now if this is the radius r, and suppose you're taking a same ring here of radius r, thickness dr. So the mistake here is basically the thickness in this case is actually dr. Here the thickness is not dr. You can't write this as small dr. The thickness here is different, rd theta, and in fact it is greater than dr. If you want to calculate the relation between small r and theta, so how will I write dr in terms of theta? Just relate these variables. So what can I write? This is theta, this is theta. So cos theta is how much? Cos theta is r by r. Capital R is constant. Now differentiate this. So when you differentiate this, you'll get minus sin theta d theta. Is this correct? Cos theta is. So when I differentiate this, I'll get minus sin theta d theta is equal to dr upon r. But why am I getting a negative sign in this? Am I making a mistake here? No, r is decreasing, that is correct. You'll get a negative sign. As you increase theta, radius is decreasing. So the point is, the thickness is r d theta, here it is dr, and dr is not r d theta. And this you can see from, without even doing all this, basically, if you have a certain thickness here dr, now if the same thickness, if I take a length like this length is not same as this length. So the thickness here is this. Is this clear? Now, if you want for homework, you can try what is the volume of a cone. Volume of a cone is 1 by 3 pi r square h. What is curved surface area of a cone? Let me write in capital letters pi r square h in case you are using smaller letters for different values. So for a right circular cone, this is the volume, 1 by 3. And the curved surface area is how much? Pi r L. I think this is the formula. So these, try to think if you can derive it on your own. And the last 4 questions, those you can ask outside the class during the lunch break of 4 to 5. Just try them once. So try to derive these 2 on your own. Now, where else is integration needed? Suppose other applications are, what is the meaning of linear density? So linear density is represented by lambda or mu. Linear density means mass per unit length. Linear mass density, it can be linear charge density as well. Linear charge density is dq by dl. Surface mass, linear mass density, surface mass density. So if I'm writing mass, it is implicit, it is mass. If it is charge, it will be q. Surface charge density means dm by dA. And if we only mention density, we mean volume mass density, which is mass per unit volume. Now, if uniform, in that case I can write lambda as m by L, sigma as mass by area, density as mass per unit volume. Now, the pens that you are writing with, is their density uniform? No. Different parts are made of different materials. The density is not uniform. So when we write density, linear density, these are all mass density. Similarly, linear charge density is also defined. So I have not written mass here, that is implicit, it is in mass. Linear charge density would be charge per unit length, charge per unit area, charge per unit volume. So suppose I want to calculate, if linear density is given to me, I want to calculate the mass of a pen or a rod. Now, suppose the linear density is 3 kg per meter and the length of the rod is 2 meters. If the linear density is uniform, if linear density is same everywhere, in that case I can write lambda as mass per unit length. In this case, what will be the mass of the rod? I can write the mass as mass per unit length into length, unitary method. So 3 into 2 will give me 6 kg. But suppose the density of the rod is not uniform, the density is varying. In that case, how will you calculate the mass of the rod? So this concept will be used in every chapter. In any question, if they want to slightly increase the difficulty level, they'll make the quantity variable. So you'll have to use integration in almost every chapter. So suppose there's a rod of length L. The length of the rod is L. Suppose I'm measuring x equals to 0 from this end. This is x equals to L. And linear density of the rod is given as lambda naught into 1 plus x by L. Suppose this is the linear density of the rod, and now they're asking you find the mass of the rod. So what is the question? They've given us the linear density. This is in SI, they're all in SI units. They've given us the linear density of the rod. The density is not uniform. So whenever a quantity is varying in this manner, we use integration. Now if they're asking you find the mass of the rod, is some constant. Lambda naught is some constant. So this is the linear density, this is some constant. X is the distance from left end. Capital L is the length of the rod. Now how will you calculate the mass of the rod in this case? So I'll just explain one question, try the next one. Suppose, basically what is the meaning of integration in this case? Now, why can't I write the mass directly in this case? Because density is not uniform. Density is changing at every point. If the density was uniform, I could have directly written the mass as lambda into length. Now, in this case, the density is not uniform. Suppose if the density is not uniform, in this case, let me choose an element. So I'm trying to divide the entire rod into small parts such that I can write the quantity that I'm trying to calculate for that small element. So at a distance x from the left end, if I choose an element of infinitesimal length dx, at a distance x from the left end, I've chosen an element of infinitesimal length dx. Dx is infinitesimally small. Infinitesimally small means as small as possible you can imagine. For this element, can I assume density to be uniform? For this element, can I assume density to be uniform? Lambda is varying with x, but if dx is infinitesimally small, for this element I can say the density is uniform. So what will be the mass of this element? So what is the element chosen here? Element of length dx at a distance x from the left end. Now, for this element, for this element, can I assume lambda to be uniform? So what can I write mass of this element as? Mass of this element, mass point length into length. And what is the value of lambda? Lambda is lambda naught 1 plus x by L into dx. What is the meaning of dm? Mass of element. What is dm here? Mass of this element. This mass of this element I am calling dm. So when we say the change, what do we mean by dm is change in mass? Suppose this is x. So his doubt was, what was the meaning of dm? If I change x by dx, I have changed x by dx. If the length of this element was m, the mass has changed by dm. So what is the mass of this element? dm. So what is the mass of the element? Lambda into dx. Now, if I divide the entire rod into infinite such small elements and write the mass of each element and add them together, I'll get the total mass. So what is integration? It is addition, and then we take a limit. Limit means the dx is approaching 0. So what will the total mass be equal to if we integrate both the sides? Now what will be the limits of x? Where is x varying from? To cover the entire rod, x should vary from 0 to L. So the total mass, this will vary from 0 to m. So total mass will be lambda naught. Sorry. This will vary from 0 to L. What is integration of lambda naught? 1. This will be x. And what is integration of x? X square by 2. And the limits will be 0 to L. So this will be lambda naught L plus L square by 2L minus lower limit is 0. So this will come out to be lambda naught. So 3 lambda naught L by 2. Is this clear? So even if this is not clear, just try to understand. The purpose of doing this right now is this we'll see in every chapter. This kind of integration will be used in almost every chapter, so you'll get used to it. Even if it is not entirely clear right now. If it is not clear, ask, but so what are we doing in this question? We are trying to find the mass of the rod. Now, the density is not uniform. Uniform means it is same everywhere in space. If the density was uniform, we could have directly said mass is mass point length into length, unitary method. Now, in this case, if the quantity is not uniform, divide the object into small elements for which I can write the, so in this case, can I divide the rod in elements like this? If I take a strip like this, to calculate the mass, I'm dividing the rod into small elements. Can I divide it into small elements like this? That is not useful. Why? In what kind of element am I trying to divide? So suppose instead of a rod, let us take a rectangular sheet. Suppose this is the origin, this is x, this is y, and they've given us sigma is varying as, first case sigma is varying as sigma naught, let's take a simple, sigma naught into x, this is length, this is the width, and so sigma naught does not have the same dimensions as sigma. The second case is sigma is varying as sigma naught y. Now, if sigma was uniform, what is the meaning of sigma? Mass per unit area. If sigma was uniform, in that case I could have written mass as sigma into area. So this is if sigma is uniform. Now, the mass density, surface mass density is varying with x in one case, it is varying with y in the other case. So, in the first case, what kind of element should I choose? In the second case, what kind of element should I choose? Why am I choosing an element? Because I cannot calculate the mass directly. Sigma is not uniform. So, what kind of element should I choose in either case? Harsha. You can either rest, don't disturb others. So write with your hand. So what kind of element should I choose? In the first case, sigma is varying with x. So I want to choose an element for which I can assume sigma to be uniform. So where is sigma uniform? At a particular x, sigma is same. So in the first case, what kind of element should I choose? Vertical strips. At a distance x, I should choose an element of thickness dx. Why? Dx is infinitesimally small. So for this element, can I say sigma is uniform for this element? So for this element, I can write mass as sigma into area. So actually, let's calculate only. So suppose, Nived, the previous question's doubt, I'll explain it in this question only. So suppose first case is sigma naught x. So in this case, what kind of element should I choose? I should choose vertical strips. Why? Because sigma is varying with x. So at a distance x, take an element of length dx. I can also choose a strip like this, but that is not useful. Why? If I choose a strip like this, at a distance y of thickness dy, for this strip is sigma same everywhere? No, x is varying for this strip. So to calculate for this strip also, I'll have to integrate. So in such cases, I mean, you can solve using that as well, but it is convenient if I choose a strip in this manner. So what kind of element am I trying to choose? An element for which I can write the quantity that I'm trying to calculate. What am I trying to calculate? Mass of the rectangular plate. So what can I write mass of this element as? So I can write the mass of this element as sigma into area. Now, because sigma for this entire strip can be assumed to be uniform, at a particular x, sigma has the same value, and dx is infinitesimally small. Infinitesimally small means as small as possible you can imagine, 0.000, just keep on placing zeros. So dx here is infinitesimally small. So for this entire shaded region, can I say sigma is same everywhere? So for this element, can I write mass as sigma into area? What is the value of sigma? Sigma naught x into dA. What will be the value of dA? What will be the value of dA? What is the area of this shaded region? Length. What is the length of this? B. What is the width? Dx. So what will be the area of this element? B into dx. Is this clear? So dm is sigma naught x into b into dx. Now integrate this. The total mass will come out to be integral of sigma naught b x dx. And what are the limits of x? What will be the limits of x? Zero to L. X to cover the entire rectangular strip. Where should I vary x from? 0 to L. It will cover the entire rectangle. So limit should be from 0 to L. So the answer will be sigma naught b. Integral of x is x square by 2. So L square by 2. Is this clear? Even if you're not understanding, please listen, because that has a benefit. Because we'll be doing this almost in every chapter. So you'll get used to it, but if you don't pay attention, these questions won't be asked directly, but this is used in a lot of questions. Now, if the same question was given as sigma is sigma naught y, now here sigma naught does not have the same dimensions as sigma, because there is length as well. Sigma naught is some constant. So in this case, what kind of element should I choose? Horizontal strips. At a distance y, take an element of length dy. Why in this manner? Because for this element I can assume the density to be uniform. Sigma is varying with y. So at a particular y, all of them will have this, at each position sigma will be the same. And dy is negligible. dy is infinitesimally small. So for this entire shaded region, I can say sigma is uniform. If sigma is uniform, I can write the mass of this element as sigma into area. What is the value of sigma? Sigma naught into y. What will be the area of this element? What will be the area of this element? L into dy. Length into width. So what is the length of this element? L. What is the width? dy. And what are the limits of y? Where is y varying from? 0 to b. So the answer will come out to be sigma naught L b square by 2. So this will be the answer in the two cases. Is this clear? Try another question. Nived, what is the doubt? So what are we trying to calculate? We have to calculate mass of this rectangular sheet. What is the meaning of sigma? Mass per unit area. But this is the definition if it is same everywhere. So in general, for a small element, we'll write sigma as mass of this small element upon area of the small element. Now density is not uniform. In this case, if the density is not uniform, we divide into small parts. How do we divide into small parts? We divide into such small parts so that we can easily write the quantity that we are trying to calculate. What are we trying to calculate? Mass. How is sigma varying? It is varying with y. So where is density same? At a particular y, density is same everywhere. So if I choose a rectangular strip of negligible thickness, dy is infinitesimally small. For this entire strip, I can assume sigma is uniform. Now, in this, I cannot choose circular rings. Each point sigma is different. I won't be able to write the mass of this. In this case, even if I choose this, a strip like this, in this case, sigma for this is also not uniform. So to calculate mass of this, I can calculate using this as well, but to calculate mass of this, I'll have to again integrate. So we choose an element for which we can write the quantity we are trying to calculate. So what is the mass of this element? This. Now divide this into infinite such strips and add the mass of each strip. That is integration. Try a similar question. Is this clear? Is this clear? So try a question. So there is a disk of radius r. Sigma is the surface mass density, sigma dot is constant. R is distance from the center. Small r, so this is surface density. So right now it is surface mass density. For surface charge density also we use sigma only. R is distance from the center. So the question is, find the mass of the disk. Find the mass of the disk. What is small r? Small r is distance from the center. R is distance from the center. So calculate the mass of the disk. This is incorrect. So try to think. So try to draw the element first. What kind of element should you choose? The radius of the disk is capital R. Sigma is surface mass density. Small r is a variable here. Small r is distance from the center of the disk. Capital R is radius of the disk. Sigma naught is some constant. We have to find the mass of the disk. So even if you are not able to solve, it's helpful just try to think what kind of element should you choose. So try to think, is this, why will this, I mean, why will this be linear method? What kind of element should you choose? So now, as Arjun has taken an element like this, you're trying to divide the disk into this kind of strips. So theoretically you can do it in this manner as well, but this will be a linear way. Why should I not choose in this manner? Why am I trying to divide the disk into smaller parts? Question. Why am I trying to divide the disk into smaller parts? Because it is not uniform. Density is different at different points. If the density was uniform, I could have directly written mass is density into area, surface density into area, lambda into L, rho into volume. What is mass of an object? Density into volume. But this can be written if density is same everywhere. Now the density is not same everywhere. The surface density is different at different points. So what kind of element should I choose? What am I trying to calculate? Mass. If I choose an element like this, what will be the problem? Is sigma same for this element? No. Even for this element, sigma is different at different points. The distance is different. So I can't even write the mass of this element. So what kind of element should I choose? For which I can calculate, write the quantity that I'm trying to calculate. I'm trying to calculate mass. So for what kind of element can I write the mass where sigma is uniform? Where is sigma same? How is sigma varying? Sigma is varying with r. What is r? Distance from the center. So at the same distance from the center, so in this case, now at a distance small r from the center, on this ring everywhere is the density same? Yes. So if I consider a ring of radius r and dr is infinitesimally small, dr is as small as possible you can imagine. For this element, can I say sigma is same everywhere? Sigma is varying from with respect to distance from the center, but for this shaded region, can I say sigma is same everywhere? So what is the element here? The element is a ring of radius r and thickness dr. Now, suppose dm is the mass of this element. What can I write dm as? Madhav. What can I write the mass of this element as? Sigma into dA, mass in, sorry, surface density into area. Now substitute the values. What is the value of sigma given as? Sigma naught r by r. What is the area of this shaded region? Length into circumference into thickness, length into thickness. So what is the area of this? 2 pi r dr. Now what will be the total mass? Integrate both sides from 0 to m. And where is r varying from? 0 to capital R. To cover the entire disk, r should vary from 0 to capital R. If r varies from 0 to capital R, the entire disk will be covered. So perform the integration. So what is the integration in this case? M will come out to be 2 pi sigma naught, 2 pi sigma naught. What is r and r? R square. So I'll get r cube by 3r. So this is 2 pi by 3, 2 pi by 3 sigma naught r square. Is this clear? Try one more question. Did you understand this? So even if you're not understanding this, please try to understand. That is important, because this will be using almost in every chapter. I mean, maybe not so much in kinematics, but in majority of the chapters, for any question, if they want to slightly increase the difficulty level, they'll make the quantity varying. So if there's a wire which has a certain resistance, they can make the resistance variable. If there's a conductor which has a certain thermal conductivity, they can make that varying. Refractive index, that is varying. So in all such cases, you'll need this. So even if you're not able to understand, as long as you're trying to understand, that is good enough. You'll get used to it. Now try one more question. So I'm writing the question here. So again, there is a sphere of radius r, and its density, this is volume mass density. Its density is varying with distance from the center of the sphere. So r is distance from the center of the sphere, capital R is radius of the sphere, rho naught is some constant.